Hello everyone, welcome back to Tinateach. This is Python List Comprehension Part 1. We'll be talking about the definition, I'll be talking about the definition of list comprehension and then the syntax as well as the usage of list comprehension because it is pretty handy. First off, what is a list comprehension? It gives you a shorter syntax when you create a new list based on a list that already has been created. Obviously, for a certain task, there are a lot of ways to write code around it. There are a lot of varieties that you can write a certain code and what it can do. And instead of writing list comprehension, you can go with a simple for loop with an if condition. So this is the longer way of creating a new list from an existing list. We have numbers 1, 2, and 3, and we have an empty new list. For x, as I've said in the last lesson, it doesn't have to be x, it could be output, it could be result, it could be I, G, whatever, all right? As long as you don't overlap it with important names like numbers, new list, and keywords. In numbers, so this is our if condition. If the string O is in X, append it to new list. Do you remember what append is? It's basically adding 1 and 2, simply add it to the new list, all right? And then print new list. As you can see, this is a rather long-winded way. You have to type a lot, so an alternative is using list comprehension that gives you a one-line syntax. Once again, we have the numbers list. For new list, we put in X for X. So once again, it calls up the for loop, but it's just a shortcut of doing it. So it's the same as, writing that is the same as this, okay? In numbers, if O in X. As you've noticed, we have the keywords that we've seen here. We have for, and we have if and if, all right? Now let's move on to the syntax. This is just a quick introduction. I'll be going deeper into what expression mean, what item mean, as well as iterable and condition in part 2 of list comprehension, all right? And something to note is that creating a new list does not affect the old list. So you can just churn out list comprehensions after list comprehensions and for loops as long as you put it in a different name. It does not affect the old list whatsoever. You can continue to reuse the old list again and again. I have some examples here before we move on to the demonstration. I have a list named countries with France, Germany, and Japan. New list. Result. Now this is in replacement of the X that you've seen here previously. Result. For result in countries. If result does not, okay? This is an opposite of this comparison operator, which is equal. This simply means does not is the opposite definition. Let me just erase this. If result does not equals to Japan, okay? And what do you think this new list will achieve? What elements do you think resides within this new list after we write this statement? It would be France and Germany because we specifically stated that result does not equal to Japan, okay? For new list number 2, milk tea for output. Once again, output is the same as result, which is also the same as X in countries. What this does is that it replaces all of the values within the list with whatever you write here. In this case is milk tea. So instead of having France, Germany, and Japan, you would just have milk tea, and milk tea. Next up is new list number 3, X upper. Now, I wonder if you remember this method. Upper is a method of having all of the strings be uppercase, okay? For X in countries, which will return the countries list, but France, Germany, and Japan all in uppercase. Let's have a list named elements, and within elements we have oxygen, nitrogen, hydrogen, lithium, sodium. En new list. So this list will simply take every element that has En within it. And for now it is empty. For I in elements, if En in I, En new list append I. And then print En new list. Now another new list with in this case. Let's do a list comprehension output for output in elements if in output. So we have lithium and sodium in here. Print new list. Potassium new list equals to potassium for X in elements. Print potassium new list. Upper new list equals to X dot upper for result in elements. Print upper new list. Control S to save. So for our for loop, we have oxygen, nitrogen, and hydrogen. As you've noticed, all have En within the elements. Next up is new list. We'll print, we'll add anything with a to new list. Therefore, we have lithium and sodium. Down here for potassium new list, we simply replace every element with potassium. So you have a bunch of potassium over here. Okay, this one returns an error. It says name error, name X is not defined. So it seems like I made a mistake over here. Result should be result X, should be X, okay? Control S to save. Let's run it one more time. There we go. Now everything is in uppercase. That's it for today's lesson. Please do stay tuned with List Comprehension Part 2. Thank you for watching, and don't forget to like and subscribe. Learn today, better tomorrow. Goodbye. Hello everyone. Welcome back to Tinateach Python. Today is Part 2 of List Comprehension. We'll be looking further into syntax analysis as well as the elements that make up the syntax, such as condition and iterable. First, let's review the syntax. I have a variable over here, a list. And this is the syntax for list comprehension, for creating, a new list. We have expression for this keyword. Words that are highlighted in blue are keywords, okay? Like for, in, and if. For item, in, iterable. If condition is equal to the Boolean value of true. Now, what does expression over here means? Expression refers to the current item that is involved in the output or the new list. For example, hello world for X in food. Now, food is an existing list, okay? So you don't need to pay much attention to it. I don't have it on the PowerPoint, but simply just imagine like a list with some elements such as like dumplings or vegetables or soup and whatnot. Now, hello for X in food. What do you think this does? Well, it replaces all of the elements in the old list food and create a new list based on that, but replaces every element with hello world, okay? Now, for our next example, X if X equals to the string hello, else the string world for x in old list. What do you think this does? Well, what this simply does is that it removes all of the elements, replacing it with world, except for elements that have the same value as hello. Okay, now this one is an easy one. X dot lower for x in old list. What do you think this lower method does? It is the opposite of upper. So if the old list has a bunch of uppercase letters, x dot lower will lower all of the cases. Next up, iterable. What does this mean? An iterable can refer to a list of tuples set a dictionary. For example, x for x in range 7 and x for x in range 5 if x is less than 2. I will give you a little bit of a demonstration for this part and all of the other parts too, as a matter of fact. Now, condition. Condition is very simple. If you look through my video about if and else syntax, it simply filters the items that evaluate to true. Evaluate to true of what? Well, of the condition that you've laid out, okay? For example, x for x in old list if x does not equal to cherry. So what would be included in the new list? Well, if you guess that the new list would have every value except for the value of cherry in the old list, you are correct. Now, x for x in old list if x does not equal 20. It does the same thing as with cherry, but it works with the number 20 instead. X for x in old list, simply copy value to value, word for word. Let's have a list that is food, dumpling, soup, vegetable, noodles, and bread. Down here we have output equals to I'd like to order for x in food. All right, print output. We'll print the output every time it changes. Now we have another output over here equals x if x equals to dumpling, else soup for x in food. Print once again. As a matter of fact, I'm just going to copy this and I only need to paste it later on. Output equals to x dot upper for x in food. Print. Output once again. We'll use the same variable throughout. X for x in range 4, and we'll see what this prints. Output equals to x for x in range 7 if x is less than 5. Output equals x for x in food if x does not equals to vegetable. Output x for x in contrast to save. For the first output, I like to order for x in food. We simply replaces every element with I like to order. For the next one, if x equals dumpling, just print dumpling. For anything else, replace it with soup. As you can see, dumpling, soup, soup, soup. And down here, we just make it uppercase because the elements are already lowercase. And for x in range 1 to 4, simply prints 0, 1, 2, 3. Okay, so it doesn't print 1, 2, 3, 4. It all starts with 0. X for x in range 7 if x is less than 5. 0, 1, 2, 3, 4. But not 5, okay? It excludes 5. So that is something you do need to watch out for because it does confuses you sometimes. X for x in food if x does not equals to vegetable. It simply prints the list but minus the vegetable element. And x for x in food, simply just copy and paste the old list, the food list, into the new output list. Well, that's it for today's lesson. Thank you for watching. Our next topic is going to be sorting and organizing. Don't forget to like and subscribe and learn today better tomorrow. Have a wonderful day. Goodbye. Hello everyone, welcome back to Tinateach Python. Today we'll be learning about sorting and organizing lists. Specifically, we'll be focusing on the sort method, the reverse method, and the key equal my function value or parameter. Now we'll be looking at the default settings for the sort method. Here I have a list of letters as well as a list of numerics. Now you can simply put letters dot sort, don't forget the parentheses, numerics dot source, and you can print them both out, and those sort alphabetically, numerically, and ascending. Okay, so it goes smallest to largest, and that is the default of the sort method. Well, we have a reverse equals true parameters for the sort method over here. Using the same two lists, we can put letters dot source, reverse equals to true. Very simple concept. Reverse is true, it will reverse the whole thing, so it goes from largest to smallest, alphabetically and numerically. Now, another thing is that you can customize your sort function using key equal function. Now, obviously, with function being in the parameter, you do have to write your own function. Here I have def my function, and we'll pass the argument of n. Return absolute n minus 50. And I have a list of numbers with the sort method passing the parameters key equal my function. Now, what you will get from this is that it will sort the numbers closest to 50 first, and then the ones that are further away from 50. So it's sorting based on the distance closest to 50 and then furthest to 50. Next up, we'll work with case insensitivity. All capital letters are sorted before lowercase ones, so that means that capital letters have a higher precedence. But this sorting can sort of be unexpected based on the values that we're giving the sort method. Now I have the list of letters A, B, and C, all different cases. It chooses the same. Some are lowercase, some are uppercase. Now you can just simply use dot source. It's sort of the default property of the sort method, so you don't need to specify anything further. Now, if you want to make the process more precise instead of the unexpected results that come with the default sorting of the sort method, you can use a function using string.lower as a key function. Chooses equals to the same list that we've seen before. We're just passing key equals string lower to sort. We're going to see what this does in Visual Studio Code in a bit. So if you're up to guessing what this will return, I suggest that you keep your guess in your mind and you see whether or not you're correct later. Last but not least, reverse order, as simple as anything that we've seen before. It just simply reverses the occurring sort in order. So whatever order that you have going on, it simply reverses all of that. And you can do that with dot reverse and parentheses. No need for any extra stuff. Letters equals to A, C, D, E, and then F. We have numerics, which can equate to any random number that you fancy, 100, 150. And then cases includes upper, lower, up, and then low. Now let's sort the letters. Letters dot sort. Then we'll print it after we sort. Numerics dot sort, print numerics. Cases, right? Cases, sort, print, cases. Let's go down here and let's have different types of sorting. Cases dot sort, key equals to string lower, then print cases. Letters dot reverse, so we're showcasing all of them. Print letters. Numerics dot sort reverse equals to the Boolean value of true. Print numerics. Next up, we're going to have a function. Def my function with parameter n, return abs n minus 20. So we're using 20 as a base. Numerics dot sort, we're reusing list instead of creating a new one. My function print numerics. Since I save automatically, I already set up to do that. If you don't forget to Ctrl+S to save, and then let's run it. So first off, we have sorting of the letters. So we have A, C, D, E, F, alphabetical, the same with numerics. And for cases, it's simply group uppercase with uppercase and lowercase with lowercase. Now, when we go with string.lower for cases, we go with lowercases first and then uppercases later. Okay, complete reverse. Now with letter reverse, we also reversed it alphabetically, and the same goes with the numerics. You can see that they're polar opposite. Now with the function over here, whichever is closest to 20 gets listed first, which is 36. You only need 16 more to get to 36, but you need 19 more to go from 1 to 20. Okay, and just moves on like that. Thank you for watching. Our next topic is going to be copying a list, so I hope that you tune in to check that out. Learn today, better tomorrow. Don't forget to like and subscribe, and see you next time. Goodbye. Hello everyone, welcome back to Tinateach Python. Today we'll be learning about copying lists, specifically the copy method and the list method. Now first we have copy. I want to be clear about the difference between the syntax of copying and referencing. If you write list2 equals to list1, for example, list2 becomes attached to list1. So any changes that list1 undergoes, list2 will also be changed. Sometimes we want that, sometimes we don't want that. That is not what copy does. What copy does is that it simply copy the elements within list1, okay? If you change list1, list2 will be the old list1. The syntax goes, we have list1, pen, pencil, and paper. For list2, we can write list1 dot the copy method, and it's as simple as that. I have the list cars and Toyota for the first element, Nissan and Ford. New list equals to cars dot copy, print new list, okay? Now another way, the list method, new list2 equals to list cars, print new list 2, okay? As you can see here, we print a new list over here and it returns list 1, the same with the list method. Now what happens if we change cars? We'll make it into, I'll make the list none and then print cars and print new list once again. And then print new list 2. Ctrl+S to save. Let's run it. Okay, as you can see, list 1 becomes none. However, new list and new list 2 remains. Okay, that's the difference. Now, if new list equals to cars, print new list. Let's run it. New list also becomes cars. And I'm going to try changing the cars list once again so you can see the relationship between them. I'm going to pass this as a Boolean. True and false, Ctrl+S, runs it again. Now new list becomes true and false. As simple as that. Thank you for watching. Our next lesson is going to be joining lists, which is a very simple thing to do, and it's quite convenient. Don't forget to like and subscribe. Learn today, better tomorrow. Goodbye. Hello everyone. Today's lesson is going to be joining lists. We'll be looking at the concatenation operator, the append method, and the extend method as well. First, with the concatenation operator, if you've never heard of the word concatenate before, it's an alternative to adding. So the concatenation operator and the arithmetic operator, they are not the same. Even though they have the same symbol, their properties are quite different. So I have a list of booleans. List 1 contains true, false, and true. List number 2 contains false, false, and false. Now I created a new list by concatenating list 1 and list 2. And if I print list 3, what do you think will be inside of list 3? It would be true, false, true, and false, false, false. Okay? Next, with appending, adding. Once again, we have list 1 and list 2. We have our little for loop over here to help with our append. For x in list 2, so we're listing all of the values, all of the list elements within list 2, and then we append them to list 1, okay? This yields the same result that we've seen here with the concatenation operator. Next up, and it's a very simple method, list 1 dot extend list 2. So elongate list 1 with the elements found in list 2. So I'm going to have list 1 with B, C, D. And list 2 is going to be a bunch of floats. 2.5, 6.3, 5.5, and 22.1. Print list 1 plus list 2. So we're going with concatenation first. As I've shown you before, we obviously can do list 3 equals list 1 plus list 2, and then you just print list 3, but you can also just do print list 1 plus list 2 if you don't really want to deal with a new variable. List 1, extend list 2. Print list 1. For x in list 2, append all of the elements in list 2 into list 1. List 1. Ctrl S, and let's run it. With our first printing statement, we have list 1 and list 2 joined over here, and the same goes with the extend. It yielded the same results. Now the for loop is giving us A, B, C, D, list 1, and then we have the same elements in list 2. What if we don't want this extra line over here? I'll just change this list 2 into list 1, and this list 1 into list 2, and print list 1. Now it's all gone. It yielded the same results as these two over here. Thank you for watching. I know that these lessons have been rather short because, we're nearing the end of, we're actually at the end of lists. So that's all for lists. We're moving on to a new data type, data sets, which is tuples. So I hope that you tune in. Thank you for watching. Don't forget to like and subscribe, and learn today, better tomorrow. Goodbye. Hello everyone, welcome back to Tinateach Python. This is our first lesson, the first part actually of learning about tuples and what they are. We'll be looking at what is the definition of tuples, its syntax, as well as properties. Let's work on the definition and the syntax first. Okay, so as you can see, tuple has a very similar structure to list. To be honest, the only thing different about tuple and list, syntax-wise, just looking at it, is the parentheses over here, okay? We have the same double quotes, the comma, item 1, 2, and 3. Now let's look at some properties of tuples. First off are the items, okay? Items are ordered. What do I mean by this? Well, they follow the index. The index start at 0, 1, 2, 3, so on and so forth. So that's what I mean by tuples are ordered. Next up, it is unchangeable. Okay, it is unchangeable. That means that once you create a variable that is a tuple, you cannot change the variable itself. You can certainly duplicate it, you can certainly copy it, and you can change that copy or that replica, but you cannot change the original, okay? And it allowed for duplicates. Well, duplicate items, okay? So you can have items that have the same value repeated in a tuple, but because it is ordered, Python has no issue with that. It can identify same values just fine using the index alone. Next up, the tuple is ordered, okay? So we're going through these one by one to get a clearer view. Ordered as in a defined order that will not change. So item 1 has the index of 0, item 2 has the index of 1, and item 3 has the index of 2. And it cannot be changed. That's just how it is once you create the tuple. Now I want to mention another interesting thing about tuple is its pronunciation. You can spell it as tuple or tuple. It's both are correct because people do use both. It's interchangeable. Okay, let's look at the next two properties. Unchangeable. You cannot change, add, or remove items after the tuple has been created. Okay, no changing, no removing, no adding of the original variable, but as I've mentioned before, you obviously can duplicate it, replicate it, and you work with that. And it allows for duplicates, okay? Items with the same value are permitted. Now, we'll be looking at the length method that we can apply to a lot of things. List, we can apply to strings, any data sets. And since tuple are one of the 4 built-in data sets, you obviously can apply the length method to it, and it will return you, the length. What do you think the length of tuple number 1 is? It is 4, okay? 1, 2, 3, 4. Now, with one item creation, sometimes, you don't really know, or you want the user to input the rest of the tuple. So you work with one item, okay? Tuple, choose one item. But there's a difference between this, and that is the comma. The comma is very important. It basically tells Python, hey, this is a tuple, okay? If you don't include the comma, Python would just take this as a singular string in a variable. Now, last but not least, with the data types, tuple can basically store anything that you can store in a data set. You can store strings, integers, and Boolean values, as well as floats and whatnot. Let's create tuple number 1 with the value of juice, coffee, lemonade, and water. Now I'm going to print the length of tuple 1 as well as print the type of tuple 1. Next up, let's have tuple number 2, and for tuple number 2, I'm just going to have cars, and I'm going to print the type of this variable. Well, it's not really a tuple, isn't it? We're missing the comma, but we want to know, what Python thinks. Tuple number 3, science, the same as tuple number 2, but this time we have the comma, and print the type of tuple 3. Okay, now I want to show you one of the property of the tuple that I've mentioned being unchangeable. Well, it's a rather nuanced aspect. So I'm going to try and assign tuple number 3 different values, okay? Science, physics, and chemistry. Then I'm gonna print tuple 3, then print tuple 1, concatenate it with tuple 3. They are both the same type, so no problem with concatenation. And let's see how it runs. Okay, everything's perfectly fine. The length of tuple 1 is 4, and it is tuple. Okay, class is tuple. However, with tuple number 2, this variable, it is classified as a string. And tuple number 3 is indeed a tuple with the help of a comma. Now you can change the value by, reassigning tuple number 3. Science, physics, and chemistry. Okay, no error there. And you can absolutely concatenate tuple number 1 with tuple number 3. Now, what if I'm going to use different methods that, the append method, the pop method, the slice method on tuple number 3. Pop, and let's see, append, right? Append. Let's append biology. Let's run it. See, tuple object has no attribute for pop. It doesn't work. You can't change it. Okay, that's what I mean by unchangeable. You cannot use methods to change the items, but if you want to reassign like I've done here, absolutely. So that's it for tuple part 1. Tuple part 2 is coming up next. Thank you for watching, and don't forget to like and subscribe. Learn today, better tomorrow. Bye. Hello everyone, welcome back to Tinateach Python. Today is our second deep dive into tuples. We'll be looking at the tuple constructor and how to access the items that are nestled within tuples. First off, let's look at the tuple constructor. So this is the syntax that we're working with. We have our seasoning variable, and then we have the tuple constructor. It basically helps to construct a tuple. It's very simple like that. And in this tuple, we have onion, garlic, and pepper for our seasoning variable. Okay. And next up, with accessing items, you can access items very much similarly to how you would access if it was a list, if it was a string for that matter. You just simply use the index with these sets of parentheses. Okay, seasoning 1. What do you think seasoning 1 value would be? It would be garlic, right? And what about seasoning at index 2? It would be pepper. Okay, what about index 0? Index 0 should always be the first one, therefore it is onion. We're going to be looking at a negative index as we've had with strings and lists. Negative index is a thing that is quite universal, and you do have to know it, even though it may seem a little bit tricky at first. So negative index starts from the end, and negative 1 as opposed to 0 is the last item, and negative 2 is the second last item, negative 3 is the third last item, so on and so forth. We have a tuple named devices over here, okay? And in devices, we have iPad, laptop, and PC. So if we're just going by regular indexing, iPad would be at number 0, laptop would be at number 1, and PC would be at number 2, okay? But with negative indexing, let me just erase this quickly because I'm running out of space. With negative indexing is negative 1, negative 2, and negative 3, okay? I also want to remind you of another property of these, index ranges is that if you put a range from 1 to 5, it would only actually print 1, 2, 4, okay? 5 is absolutely excluded, and the same applies with negative indexing, okay? So we have negative 2. What would negative 2 be? It would be laptop. Negative 1, it would be PC. I want you to hold off on your guess on these two because I'm going to showcase them later. It'll be more interesting that way, okay? Last but not least, we have item checking using the in keyword. we have our good devices tuple over here. If iPad in devices, very easy to understand. If the value iPad is actually in the tuple devices, print yes, iPad is in the devices tuple. Else, aka if not or if otherwise, print no iPad here. Now let's create a tuple devices. We start off with a variable. I'm going to use the tuple constructor, remember, double parenthesis. And let's have laptop, earphone, microphone. And then let's try printing out some indexes. Devices, let's go with 2, print devices one more time, -3 till -1, and then -3 till -2, okay? Now let's not have any numbers at all, and let's see what it prints. Then next up, let's do some checking. If laptop in devices, print laptops are up for sales, okay? Else, print, unfortunately, you have to go somewhere else, okay? Whoops, address the save, okay? I think that's it for now, right? Let's run it. Okay, 0 to 2, we have laptop and earphone. Then we have -3 to -1, we have laptop and earphone one more time. But with -3 to -2, we only have laptop, okay? If you do not pass in any index range, it gives you the whole thing. Now, laptop is indeed in devices, okay? So it will print laptops are up for sale. But what if it's not laptop? What if it's something like cookie? As you can see, unfortunately, you have to go somewhere else. Very convenient. Now that's it for our lesson. Our next topic is going to be about updating tuples, okay? We're going to be looking at the unchangeability property of tuple and how we can work around it. Certainly there, with programming, there are many loopholes as long as you're creative enough. So thank you for watching. I hope that you stay updated, and don't forget to like and subscribe. Learn today, better tomorrow. Goodbye. Hello everyone, welcome back to Tinateach. Today we'll be looking at how to update tuples, specifically with changing item values, adding and removing items. So this will be touching on the unchangeability property of tuples that I mentioned on our first lesson regarding tuples. And we're going to look at, the different workarounds, the different loopholes that we can jump through with this particular data set. First off, with changing values, now I want to remind you once again, tuples are unchangeable or interchangeably immutable, but you can certainly take advantage of other built-in data sets by converting a tuple into a list. Change the list, then you can convert it back into the tuple how you need it to be. So I have a little bit of a demonstration over here. I have tuple, okay, with hello, hey, and hi. Now, with list1 is a new variable, and we can use the list constructor, okay? Very convenient. We use the list constructor to make tuple1 a list. Now, since tuple has become list1, we start working on the items within list1, which is once again identical to tuple1. So we're working with index number 2, which is 0, 1, 2 is hi, and we turn it into what's up, okay? Now that we're done with all of the modifications and all of the changing, we can once again turn the tuple into its old data type. We have the tuple constructor, and it's passing in list1. Okay, so now list1 becomes tuple1. Now with adding items, immutable tuples do not recognize the append method, unlike other data types. and data sets that allow for changing the values, the items. But certainly, as I've mentioned before, there are loopholes and there are workarounds. Once again, list1 equals to list constructor with tuple 1, and we can use append on list, okay, because lists are not immutable. They can certainly be changed and modified however you like. Then you just turn it back around again with the tuple constructor. Now, another interesting thing with adding items is that you can certainly add tuples to tuples. You cannot change tuples, but you can add them together to make something new. So technically, you're not modifying what has existed. You're simply creating something new out of old things that remain the same. So in a sense, you're not violating the immutable property of tuples. Here I have tuple number 2 with candy, chocolate, and gummy. Tuple number 3 with cake. Be reminded of the comma. Without the comma, this is simply a string. And tuple 2 plus tuple 3, right? Last but not least, removing items, okay? Now I have a tuple over here, red, yellow, and blue, and I convert it into a list using a list constructor, and I rename it into make list, okay? Now I apply the remove method to make the list in order to remove the last value, which is blue, okay? Now I convert make list into a tuple once again with a tuple constructor, and I rename it colors, the OG name. Now you can certainly delete tuples as I've done here with the fruits tuple. Now if you try to print it or you're trying to work on it somehow, it will return an error saying that this tuple no longer exists. Now let's make this quick. I'm going to create a tuple called colors, and let's have a lot of things in here. We have brown, pink, blue, orange, okay. Now let's create another one named colors 2, and in colors 2 we have, let's say, red, okay, only a singular value. And now I'm gonna make colors into a list so I can modify it. And into list append, let's see, white, okay. Into list remove blue, like that, blue. And then I want to add colors 2 with into list colors 2, okay. Now let's convert it back into a tuple using the original name colors tuple into list. Then let's print colors, okay. As you can see here, we have brown, and certainly we have pink. However, we do not have blue because we removed blue already, and we have white instead. And we have the red that we got from joining with colors 2, okay. Now let's work with delete colors, print colors. Okay, as you can see here, colors not defined, to show me in color 2. So that's it for today's lesson. Our next topic is going to be about unpacking tuple. So it's going to be quite an interesting topic. I hope that you tune in. Once again, thank you for watching. Don't forget to like and subscribe. Learn today, better tomorrow. Goodbye.